Hello everyone. In the previous video, we had understood about method of least squares, and using method of least squares, how did we arrive at the normal equations? We had seen for a regression equation, y on x, that is for y equal to a plus bx, the normal equations or we found that in the previous video the normal equations are, first one is sum y equal to na plus b sum x, and the second normal equation is sum xy equal to a sum x plus b sum x square, b sum x square. So this equations we arrived using the partial differentiation and maxima minima principle of a differential calculus. Instead, we will also see the alternative way of arriving at these two equations. Let me call this as equation 1 and equation 2. Now let us go back to this equation. What do you call y equal to? I will say alternative way of arriving at normal equations. One thing is clear that we know in y equal to a plus bx, a and b are constants and x comma y are variables. Suppose if we have n pairs of data x comma y, then I can say y will take the values, because it is variable, I will say y will take values y1, y2 and so on up to yn. Whereas a is a constant, it will remain as it is. And even b is also a constant, it will remain the same. Whereas x is a variable, so when y takes y1 value, then x will take x1 value, corresponding values. So these are the different equations. Now, if I add all these equations, what do we get? Left hand side, you will get y1 plus y2 plus and so on yn. Right hand side, a plus a and so on up to a. That means there are n a's available. So I will write it as n times a. Here, if you look into b is constant in all these things, common. So I can take b outside. Then I can write it as x1 plus x2 plus and so on up to xn. Now, what is this and what is this? This I can express it as summation of y. This will remain as NA, and this I will express it as summation of Px. That is what is our first normal equation. See, y summation y equal to Na plus Px. So we can arrive at this one normal equation like this also. Now, for the second normal equation, let us go back to the equation. What is that? Y equal to a plus bx. Let us go back to that once again. Y equal to a plus bx. So multiplying both sides by x, we get what? We will get x into y equal to a times x plus b times x into x, it becomes x square. Again, applying the same logic, x and y's are variables, and if it takes, let's say, n values, suppose x takes values x1, x2, and so on up to xn, and y takes values y1, y2, and so on up to yn. Then let's move on to the next page. Then I can write this xy as x1, y1. A is a constant, this will be x1. B is a constant, this will be x1 square. Then the next value I can write it as x2, y2 equal to a x2 plus b times x2 square. Likewise, nth value xn, yn equal to a times xn plus b times xn square. Now again, if I add this, left hand side will become x1, y1 plus x2, y2 plus and so on xn, yn. And the right hand side, you may find here a is constant, here b is constant. So a times x1 common. So a times x1 plus x2 and so on up to xn plus b times x1 square plus x2 square plus and so on up to xn square. So this I can rewrite it as summation of xy equal to a summation x plus b summation x square. This is our second normal equation. If you look into, you may land up with the same. Sum xy equal to a sum x plus b sum x square. See, it is the second equation. So this is the alternative way of understanding how did we arrive at the normal equations. So I can say solving equations 1 and 2 will give us values of a and b, which can then be substituted in equation y equal to a plus bx, so that for any known values of x, we can forecast values of y. That is the advantage of regression, right? So if you find this video to be useful to you, I request you to please like, share, and subscribe to my channel. Take care. Thank you very much.